Hello everybody, how are we all doing? I just wanted to quickly share a video regarding a refrigerant flow diagram. So you might be familiar with a refrigerant flow diagram. Sort of simple ones will have a compressor, evaporator, condenser, and metering device. So this works exactly the same way, we just might have more of those components. So what we've got in front of us is the Hitachi Air 365 Max heat recovery 3-pipe system. So this might be hopefully useful if you're possibly an apprentice or you're new to VRF or you're just a bit unsure what all that copper pipe swirling around in that outdoor unit's actually doing. And hopefully it might sort of point you in the right direction of what you'd expect to be hot, cold, and that sort of things. So what we're going to do is we're going to run these units in heating and cooling, and we'll run them in mixed mode as well, and just go through this sort of the flow of refrigerant through the system and how it all works. So that's our state at the moment. So we've got everything turned off. So component wise, we have our compressor. This is an inverter gas injection compressor. On the bigger systems would have a second one. We've got our condenser coil. And again, if we had the bigger units, we'd have a second condenser coil. And then our indoors are where our evaporators are. And each indoor has its own expansion valve. Now we do have other expansion valves. We have one at the outdoor that feeds the outdoor coil, so when that outdoor coil is being used as an evaporator, we've got an expansion valve that feeds it. We also have an expansion valve here, so this is our mechanical subcooler, so we use the liquid line to feed that mechanical subcooler to reduce the liquid line temperature. And then the other place we've got them is inside our CH boxes. So the reason these are used inside the CH boxes is not to throttle refrigerant as such, but more to use it as an equivalent of a solenoid valve. The reason why they use expansion valves is because they're much quieter, because you'll have discharge gas or suction gas depending on the mode, and it's allows for much quieter operation than using a solenoid valve. We've also got some four-way valves here, and then we've got some solenoid valves dotted around as well. We're not going to go too much into detail with them. We're going to mainly focus on the major components and where the refrigerant flow goes through. So let's turn this unit into cooling. So that's in cooling. That's now cooling mode. So as you can see, that discharge gas is starting to work its way through. So our compressor here. So off the top here, you can see the high pressure, high temperature discharge refrigerant. You can also see this little line here, so that is part of the oil balance. So these compressors are under high pressure. It uses discharge gas to cool the oil set, and the pressure difference is used to push the oil up the shaft of the compressor and stuff like that. So our discharge gas works its way across here, so our oil separators here, so that oil will migrate back down into the common suction and work its way back to the compressor. Two four-way valves at the moment, that one's diverting it, but this one's diverted it to the outdoor coil, so this is going to be our condenser. So our high pressure, high temperature discharge gas works its way through and into the coil. Now at first that's going to go through a sensible heat change because we're going to drop the temperature slightly, so we're de-superheating that discharge gas before it goes into a saturated mix. Once it's in a saturated mix, it goes through a latent heat change where we're changing the state, not the temperature. And once it's changed its state into a liquid, we're then going to subcool that liquid to make sure that we've got a full body column of liquid going through. So we're going from a high pressure, high temperature discharge gas into a high pressure, medium temperature liquid. That liquid will then work its way around into the subcooler. So this is the bottom portion of the coil, so this is part of the subcooling part. It's going to work its way through along the liquid line, and then we're going to tee off here as well. So that expansion valve is further reducing the temperature of the liquid, because the lower the temperature of the liquid line, the more efficiencies we get. And that refrigerant is also going to be used to feed the compressor on the vapor injection. So this will then tee off into your various indoor units. So this one's not being used, so the valve is closed, and as you can see it comes through here into the expansion valve, which will start the refrigerant, and then that high pressure, medium temperature liquid refrigerant is then going to start to boil off, and that is then going to go through another latent heat change from a high pressure, medium temperature liquid into a low pressure, low temperature vapor. and then it's going to superheat slightly because we don't want any liquid coming back to our compressor, and that's going to work its way through here. Now you'll notice we're both using both pipes, so we're using the suction and we're using the high pressure, low pressure as well as a common suction. So it's going to use both of these. So this expansion valve will be fully open, and this one's going to be partly open to allow to use this extra pipe, and that's going to make its way back through the four-way valve, back through here, and then into our accumulator, and then off the top of the accumulator back into the compressor. So now what we're going to do is we're going to turn this one on. So that unit is now on. You can see that liquid refrigerant going through the coil, so it's going through the exact same process as that, and then it's going to feed into that. So that system, if you had multiple of these, you could have them all in cooling, so that system is in cooling mode. Now we're going to go for mixed mode, so we're going to turn this one into heating. So as you noticed, this four-way valve is now shifted over, allowing discharge refrigerant through. So that expansion valve is obviously closed. So as it comes through here, it's going to go through into the indoor unit. So again, this is going to be high pressure, high temperature discharge refrigerant. It's going to go for a latent phase change again. So it's going to go from high pressure, high temperature vapor into a high pressure, medium temperature liquid. And then that liquid, so the reason why we're using heat recovery is that liquid can then feed other indoor units, as well as liquid coming back from the condenser. So now we're going to put this unit into heating. So at the moment we're working mixed mode. So it could be a case that if you had more units in heating than you had in cooling, then this would turn to evaporator. But for our processes, we're mixed mode, but we're mainly cooling. So we're using the condensed coil and one of the indoors. So let's put this one into heating. So that's now in heating mode. And as you see, that expansion valve is opened up to allow discharge refrigerant in, and that's now feeding that coil with high pressure, high temperature vapor, which is now going through a latent phase change into a high pressure, medium temperature liquid. So now we can see that our outdoor coil is now the evaporator. So this liquid will come back through the mechanical subcooler into the bottom portion of the coil to subcool it even further, and then it goes to the expansion valve. So our medium temperature, high pressure liquid is going to go through into the coil, go through another latent phase change. So we're changing the state, not the temperature, into a low pressure, low temperature vapor, and that's going to come down into our common suction, into our accumulator, and back into the compressor, and that's effectively it. So we've got all the same components you would have on a standard. We just have the additional pipe coming out of the outdoor unit, our high and low pressure, which just allows us to have the indoors and simultaneous heating and cooling with the use of the CH boxes, and we've got some four-way valves. But effectively it works exactly like every other refrigeration system. We just have a few extra things on there for efficiencies. But if you found this helpful, let me know. If you've got any questions, let me know. If I've got anything wrong, let me know. But yeah, hope it helps everybody. Hope you have a good day and a good weekend. Cheers guys.